I have to record. I have to start recording as well. All right. Hope you guys can see my screen. Online, guys.
Yes, sir. Yes, sir. Now we can see.
Yeah. So I'll start with the agenda, what we are going to cover today and tomorrow, and then we'll resume with what we did in last class. If you have any question and answer, we can quickly clarify it. Then we'll move with the as per agenda. So agenda. So actually, it's a topic-wise called getting started with Hadoop. Namrata, still you have issue with my voice? I mean, is that
It's a bit better.
all right? So getting started with Hadoop, we are going to talk about the big data, right? So what is big data? So by definition, we'll talk about the big data. We'll try to talk about the different use cases. Thanks for confirmation, guys. Okay. So we'll talk about what is the big data and what are the big data scenario. And so we'll also talk about what is the what is the requirement behind having this big data. Big data or Hadoop as a technology, right? So this is what we'll talk about. Then we'll start with the architecture. What is Hadoop architecture? So there inside the architecture, we'll talk about standalone. We'll talk about pseudo distributed. And then we'll talk about cluster distribution. Okay. And also we'll talk about right sizing perspective. What kind of right sizing of the cluster? So right sizing, what does it mean? So we'll have to understand what exactly should be size of your cluster in ideal scenario, based on the different use cases, based on the different requirement. What should be size of the cluster, right? And architecture perspective, there will also discuss about a high level core component. So there we'll also discuss about master and slave architecture, what we have in Hadoop cluster, right? So this is primarily we are going to discuss on today and tomorrow, where we are trying to, first of all, we are trying to establish the context. We are trying to build the base. What is the big data all about? How we can take it up? What is the big data concept itself? What are the different problem use cases we have around the big data? What are the analytical use cases we have? How we can position, where are the areas where we can position big data as a solution? Where are the opportunities where we can fit this big data kind of technology? It's not only big data. So we will also talk about analytics perspective as well. What are the different use cases you can do actually, right? So once we are comfortable with the big data definition itself and how we can correlate, what is actually why we have the Hadoop nowadays, why as a technology, what are the core concept, what is the design perspective, what is the internal architecture, why they came up with this kind of technology, why it's having we'll also discuss about differentiation factor with your legacy database. You have already databases which is actually doing all those kind of jobs, right? How we are fitting Hadoop as a technology within your legacy data warehouse system. What kind of the new architecture we are following. So when we are talking about the architecture, I will also discuss about the two type of architecture which is quite popular architecture. So Lambda architecture and Jita based architecture, right? So we'll also compare with the legacy data warehouse, right? So this is the whole idea. I think this is very important perspective. Holistically, if you will try to understand how this entirely your this Hadoop technology is fitting into the system, right? So for the guys who's actually quite freshers, probably there are a couple of new words, not couple of few words you'll find it's pretty new for you guys are who are actually just passed out or starting career. So if you have any questions about the new buzzword or keywords we are going to talk about, so feel free to raise your questions. The way we'll go with the class, what we are expecting, so I'll go with the flow of class, right? Whatever the lectures, whatever the slides I will go on. And then at the end of this particular topic, once I'm done with the topic, I'll allow sometimes you guys to speak up or come up with your questions, right? So unless you just have a patience, probably whatever the questions out of curiosity you have, I'm going to cover in slides as itself. If it's not covered, then definitely you just write down your question on your notepad. I'll give enough time to talk about your questions and clarifications, right? So this is how we'll proceed as per the, I would say, discipline we go with the class. Now, last Sunday we started with this Hadoop as a big data certified course. So there we talked about different, I mean, how the class schedule is, what are the different topics, what are the content. We are going to talk about how many classes we have, what are the ways you're going to interact with us, and also we'll talk. We talked about how you can, what are the softwares we are going to use during our practice and entire course. So if you have any questions, or clarifications required, feel free to ask me.
Hi, Pendra, this is Raj Kamal.
Yes.
Hello. I downloaded the software that you told us, VMware Workstation and Cloudera ka wo wala. But is there any application we have to open on that cloud computer? Because I was trying to open Cloudera's applications and it told me that I should have at least 8 GB RAM allocated to Cloudera's platform to run.
That's absolutely true. So at least minimum configuration, minimum configuration you should have with your system. So RAM, I would suggest you should go with the, I mean, your dedicated laptop, you should more than 12 plus GB RAM, right? So 12 plus GB RAM and hard disk, if you talk about, so at least 100 GB hard disk. CPU at minimum i3 or i3 plus, right? This is the minimum configuration required. If you really wanted to full flash play with all components we have there in the Cloudera setup, right? This is the minimum configurations. There are ways to go with even less configuration, but that is not ideal practice as of now, guys, for you being a fresher, being a newbie to this technology. Because it will create lots of challenges and problem to deal with the installation and setup. Then you will just engage with the installation and configuration rather than your focus on learning perspective. So I would suggest go with the at least 12 plus 12 GB plus gig of RAM, and you should dedicate at least out of 12 gig RAM, you should dedicate 10 GB RAM to your virtual machine.
Okay, and how long will be practicing on the case studies before the case? How long will we take the case studies to the case studies? Like 2-3 classes before we get to the case studies and working on the Cloudera's platform, because that would buy me time to buy a new RAM and install into my computer.
Got it. I think, yeah, as I told in last class, we have at least couple of weeks,
Okay.
Yes. So you have at least couple of not at least couple of classes, right? So at least
Okay.
2-3 classes you will go with the theoretical, will go with the architecture concept, and will go with the Linux command and setup. So you have at least 2-3 classes to get ready with your machine.
Okay.
Right. And
Right.
back to your question again. The one problem which I actually encountered during the installation, in fact, last time I have already informed you guys, the virtualization setup, Intel virtualization, you have to enable. By default it is disabled, but you can so you have to check if it's not, your virtual machine is not coming up while powering on. So you should definitely look into virtualization.
I would be able to install it through the command, though the installation suggestions that you have shared is pointed out to the not to the latest version of the Cloudera. It is pointed out to, I guess, 5.8 or 5.10, and now it is 5.14. So they changed a bit, but it's quite user friendly, and I guess everyone would be able to download it and install into their computer, because I have done it and I face no problem with that, except that my RAM is quite low compared to what is asked of me.
Right. So in the document itself, you'll find the older version of the Cloudera downloads, right? It does not matter.
Right.
When you'll go to Cloudera website, you'll find always latest version of Cloudera, right?
Yeah.
So you just download it and follow the process, rest of the process as mentioned in the installation document, right?
Yep.
Any other questions, guys, if you have?
If our system do not support 12 GB of RAM, then we can go to the old version of Cloudera.
Older version of Cloudera, you can find 5.34, then probably it is going to work with even less than 8 GB of RAM. But I don't think you'll find older version there. You cannot down. 5 was also not available. You cannot find there, because Cloudera always recommend with the latest version, and it does not make sense to go with the older version. There are lots of changes has happened within the Cloudera environment, so you should always go with the latest version, right? They have introduced lots of concept, lots of new technology. They have fixed lots of bugs with the older version.
Okay. Even I have this problem. I just have 4 GB RAM on my computer. With this, I've earlier tried with Ubuntu. That works just by starting all those daemons and nodes manually. So will that work? I have Pig and Hive installed in that, and I can use Chrome and Scoop with that also.
See, as far as you are able to do your assignments, first thing, and you are able to do your practice, I'm okay. But don't expect any support from our side on Ubuntu. If there is something wrong with Ubuntu or installation and setup, so we definitely will help out with the best effort basis, but don't expect any support from our side. So because it actually requires lots of effort to set up it up on the Ubuntu. However, it's good. I mean, if you really wanted to go with less memory or RAM, so you can go with your open source version of the Hadoop. You can download open source. You have Ubuntu as a bare metal machine install on your laptop, or you have virtualization. enabled. You can even Ubuntu install on virtual machine, and then on top of that you can install Apache Hadoop. So I think this is the good practice if really wanted to learn inside nitty-gritty or inside the core component or the core areas of the Hadoop itself. It's best to go with the installation of bare metal, but that's not always recommended, because I mean the pace we are taking up with the learning, so it actually requires, rather than struggling with the administration process, you better focus on as a analytics, as a user, as a rather than administration perspective. All this time getting aligned to delete. It's better you focus on the Cloudera, which is pre-installed. Our whole idea is, our focus is not to be administrator. Our idea is to be user, data science or data analyst or developer perspective, right? But over the period, if you, I mean, once you're done with the class, definitely you should try to install, set up your own cluster on Ubuntu. This is really going to give you enough exposure on the Cloudera or Apache Hadoop side.
Okay.
Yes.
Just for the starting, like first 1 or 2 sessions, can I do that practical on that on Ubuntu machine? I can try that one on.
Yeah, you can do that. I mean, for first few classes. Which class? Okay. Even first few class, when we are talking about, we'll go with the refresher, SQL or Linux refreshers. You can use that your Ubuntu. So my whole idea, as far as you are able to do your all practice, you are able to submit your assignments, I'm okay. It does not matter whether you're going with the Cloudera, any kind of technology, whether you're picking up the Cloudera, cloud version Hadoop, right? My only concern is if you're expecting some kind of support, then there would be little challenge from our side, right? Otherwise you are free to adopt any kind of software or version. You just focus on your learning over the, I mean, moreover, each and every version, they are almost same. There are small differences you'll find. So that is definitely, I can help you out if something is not working in hot on or something is working in Cloudera. What are the major differences? I can help you out. So you're free to adopt any kind of environment, but recommended is go with the Cloudera version, so that you can pace up with you can align your learning with the class. Any other questions before?
Yes, so if we are using this Cloudera version, so now there will be any difference now in enterprise edition when we will work in organization, or environment would be same?
So there would not be any difference at all as far as services and concern. You'll find same look and feel, but there would be difference on a cluster perspective. As of now, you're actually working on a single node, but the moment you go with the enterprise specific, then there would be cluster. There would be multiple nodes. But as a user, you won't be having any kind of impact. It will look and feel and interface would be exactly same, right? So I'll tell you what would be difference when you're going with the real production environment, how the architecture looks like, how the interface looks like, where you have to log in, where you have to start up, how you connect your machine clusters. I'll go through with all these steps, so you'd be pretty comfortable even you're migrating from your trial version or your training version to enterprise or production environment. Right? Any other questions, guys? So online guys, any questions from your side? All right, now let's start. So We'll start with rather than Hadoop. So whenever we talk about Hadoop, right? So by default, whenever we talked about, in fact, Hadoop, big data. So by default, Hadoop comes into picture, right? Whenever we talked about big data. Do you know big data? By default, it's like, he must be talking about Hadoop, Cloudera, Hot Works, or Map or something kind of technology, right? So we can say Hadoop is being used as a synonym for the big data word, right? But what is the big data actually? It's being used as a synonym, but it's not exactly, I mean, if you go with the definition itself, it's not exactly same, right? But what is the big data? What we call big data, right? So is it technology? Is it solution? Or is it a problem? Or is it some platform we are talking about, right? So when we talk about the big data, we definitely relate to Hadoop. Hadoop is a platform, right? Hadoop is a platform, but so what is the big data? If you have any, I mean, if you have an answer, please respond with your answer. What is the big data?
Any of these, it's just unregulated.
So, big data is a problem.
Okay.
So any large
So,
cluster of data put together.
It's working with high volume data that probably changes too frequently or too often with a high velocity and too much of a variation in terms of formats or structures.
high volume, high velocity, and we talked, and someone said about this is the problem, right? Big data is a problem. Right? What about you guys? What do you have a perspective around big data?
Platform.
So big
Data
data
is a
is really a
platform.
large data sets, a combination of large data sets.
Combination of, can you speak little loud?
So basically, big data is large data sets combined a large data set, combination of large data sets.
Large data sets. Okay.
Big data is a collection of large data sets. Data set can be in any form. That will be structure, unstructured, or it can be any of the form.
All right. Okay. So there are lots of misconception, I would say, or myth around the big data, right? So if you talk about what is the big data, so these are the myths generally being talked about, right? So it's a big, you need to have a lot of data to talk about the big data. If it's big data, then it's big data. I mean, size of the data is big, so it's treated as a big data, right? So sometimes we call it's big data, we have to apply it the right way. And if we have a big data, it means we have a good data, right? So we have also seen a myth, right? If we have a big data, we don't have, worry about the granular level of the data because we have the big data, right? So these are the some myths we have, perceptions around the big data, right? So actual definition is there is 4 V's of the big data. If you go with the big data, there is exact definition. Earlier it used to be 3 V's. 3 V's: volume, variety, and velocity. Now veracity is also added. That's called the 4 V's of the big data. 4 V's of the big data. So if your data qualify these 4 quality, then you can treat it as a big data problem. right? It's a big data. So what is the 4 V's? First is volume. Definitely, if you have a volume, I mean, humongous data, you can treat it as big data. But that does not exactly completely qualify, right? It's complete a big data. So big data is also, it should be variety of data. It's not only structured, it's talking about unstructured, semi-structured, audio, video, any kind of data. I mean, it's mix of the variety of data, then you can say one of the qualifying criteria for the big data. Then we have the veracity. So veracity means definitely data should be on some trusted source. If your data is like junk data, it's untrusted source, it's not carrying right facts, so you cannot find right information out of the data, right? So it all means if your data is junk or corrupted, so garbage in, garbage out. Whatever you're putting into your analytics model, whatever you're analyzing, if you have a junk data or garbage data, so your model is leading to some different conclusion, which can be wrong to your business perspective. So veracity of data is very important. Later on, it has been added as a fourth features of the big data, where it's talking about your data should carrying proper facts and figure. It should come from it should be coming from proper authenticated source. You can rely on your data, right? So why we have, because earlier it used to be whatever the data you're getting, whether it's having any meaningful information or not, it's just data. So it does not make any sense to do any kind of analysis, right? If it's not carrying any, though it's a big data, but it's not having proper information, carrying proper information from authenticated source, so you'll not get out good information out of that data. So it does not make sense to store, curate, or do an analysis around that data. It's junk data, right? So so third one is, I would say you should go with the volume, variety, velocity, and the veracity. Veracity fourth is added later on as a definition. So velocity means now your data is coming with a very fast speed. Your data is growing with a very fast speed, right? Now we have the situation we are seeing due to digitalization, due to using of the latest technology, and our data is actually growing with the very speed. And it's not only in one variety, it's increasing with the multiple variety, be it social data, be it unstructured, structured data. Lots of different kind of data is getting generated with very good speeds, right? If these four quality if satisfy your data, then you can say this is the problem, or this is the big data, and it is qualifying the big data problem. So you can apply. So whenever we talk about the big data as a definition, then definitely you should just talk about these 4 V's. Don't try to relate with the technology, right? Because today we have Hadoop, there could be a different technology, a platform to solve. These are the technology which actually enables you to deal with a big data kind of problems. They are not actually qualifying as a big data. But nowadays we are actually using synonym. If you're talking about the big data, so it's just Hadoop. So Hadoop is a platform. So instead of Hadoop, you can go even nowadays. If you go with the AWS altogether, they introduced their own platform. Though they have adopted few facts of big data Hadoop, but they have altogether came up with the EMR, Elastic Map Reduce kind of technology, right? So if you go with the company to company, it is varying. Platform is varying. It is named as a different way. But if you talk about the big data definition, they are actually, you should just focus about these 4 V's, right? So it's very interesting infographics we are talking about. So this is actually you can say about what is the volume, where these volumes are coming, how the volume of data is increasing, what are the different variety, from where different varieties of data we are getting, with social media, with RDMA structured database, unstructured database, and video, audio. Now if you look about image analytics, spatial analytics, video analytics, all these are the part of big data problem, because they are carrying varieties of the data, right? Then velocity, as I said, I mean, data is growing in a very fast speed, right? So if you go with the now we are talking about IoT. IoT is another one more new buzzword we can say. This is one more new technology which is coming into place. So IoT is actually Internet of Things. With the Internet of Things, you are actually having lots of sensors placed somewhere, and you have integrated all those sensors and trying to capture some information, and that information is nothing but it's generating lots of data using that sensor in a very fast speed. And then once data is actually getting generated, then you are analyzing. For analyzing with the fast speed of the data, so this is the Hadoop kind of platform you can use, right? So just for information, what speed data is actually growing. This is the stats we have with the 2016, where you can see, right, in 1 internet minute. So within a 60 seconds, right, what is happening? So you can say Netflix is having around 69,444 hours video being watched within a minute around the globe, right? So you can assume what amount of data is getting generated, the size of data is getting generated, right? So these are the few information you can say, few organizations which is actually generating huge amount of data. So capture, to analyze, to deal with this kind of data, so we need some kind of platform which can actually help. This is not going to help you. Your legacy databases which we are using so far, be it Oracle, be it MS SQL, or any kind of database we have been using so far as a RDBMS technology, they are not able to deal with, right? They have their own value propositions. We have to think about where. So it does not, since we are moving with the new technology which is called Hadoop, right? It does not make, we should, it does not, looks like we should ignore our previous learning what we have so far with the RDBMS. So those legacy databases still exist, and they have their own value proposition, where you can differentiate, where you can use your old technology as a RDBMS, and where you can use as a Hadoop technology to solve this kind of problem. So we'll discuss in detail. We'll try to differentiate, because that is the one area you can you can try to. Sometimes this Hadoop, definitely Hadoop is a very good technology, but it is not always useful to fit everywhere, right? If you have a small set of data, it does not make sense to go with the Hadoop kind of technology. You can better do analysis using your RDBMS technology, right? So if you're going with your transaction management, Hadoop is not going to fit, right? If you have application which is actually using transaction management kind of feature, so Hadoop is not going to fit at all in that scenario. So you have to live with your RDBMS kind of technology. So these are the situation we have to understand, but how both. So I mean, over the period, you'll understand how you can fit what kind of technology is fitting into which situation. AC चाहिए अब लोगों को? Okay. So, right. So now this is something, I mean, beautifully explained how within a 1 minute, right, what amount of data is getting generated, what are those major organizations which is contributing this data, and this data is now very, very useful, and they are living only with the data, right? So they are living now. One of the very good article I have gone through. Now your so now so earlier we used to call about oil field. So oil field is gold mine for you, right? So where you're generating huge amount of money by exploration of your oils. I mean, now oil field, it has surpassed your oil field. Now this data is actually your gold mine. If you're managing, if you're having data, I mean different variety of data, if you're managing with the very good way and with the right source, so you can convert in dollar values. So what are the different sources? Though these are the major sources we talked about, but if you look at here, what are the different sources which is actually generating a big data, and they are qualifying as a big data problem? So you can talk about, these are the few listed sources. But this is the sample we have listed over here. But whenever you think about, these are the 4 criteria, any kind of situations qualifying this criteria, you can convert it as a big data problems. You can blindly, go with your big data problem. So if now this is one more stats. I mean, how the data is actually growing. So we have seen, right, one of the prediction from IDCA, International Data Corporation. They are actually doing lots of research around the data. So they have predicted, right, the growth of digital, just because of digital adoption across the world, how the size of data is growing. So in 2009 it used to be 0.8 gigabytes. Now it is grown, it is going with the 44 factors, and 2020 it is going to be 35.2 gigabytes of data, right? Since data is growing, variety of data is growing, so we should have some kind of platform which can actually help to deal with the data. So even before this was the kind of problem earlier they have realized, and that's why they started thinking about we should have some technology which can actually help to deal with this kind of problem, right? So we understand the size of data is growing, the variety of data is growing, but at the same time we have the challenges, right? Now in this age we are learning about this Hadoop kind of technology. It's been uh, right. Otherwise the growth of data has started long back. So everyone was struggling. Even if you go with your current organization, there are many jobs which is actually, if you have ETL job design and running in your data warehouse, probably it might be running 4 hours, 5 hours, right? And then you are getting some information after running those ETL jobs, right? 4-5 hours is definitely even this scenario. If you go with the organization, job are still running for 4-5 hours. But if you go with the market trend, the reality and economy of the market, it's moving very fast, right? So now even 4-5 hours ETL. So if your job is running 4-5 hours and getting some information, you have massaged something and you're extracting some information by running that ETL job, then you're ready with some analysis after 4-5 hours, right? It is not going to help you out. You need some kind of technology which can actually enable you to deal with the very fast analysis, right? So along with the cap analysis, you should also think about, you should have some kind of platform which can actually do quick analysis. Why we need a quick analysis? Why? What are the requirements? Definitely, we are going to talk about what are the different use cases and scenario we actually need a quick analysis, right? Otherwise, what will happen? Even with my previous organization when I was working, so we were having lots of trouble around this ETL jobs. We have scheduled ETL jobs, and over the weekend we have executed jobs. This is going to be executed. It is being monitoring, and we are expecting by the time we are coming into office on Monday, our report should be ready so that we can do some. We can share with our leadership so that they can plan their meeting and presentation with the client or customer. So what will happen eventually? We were actually, even the job was running over the weekend, but we realized job has failed. By the time Monday morning we are coming into office, job has failed, right? So over the weekend, your job executed, and by the time you came into the office, your job has failed. You don't have data to be shared with your leadership. And what has happened? Consequences: your boss is not able to present, or you would not be able to present your scheduled presentation to client or customer or within the team. So it is ultimately, losing time as well as the money, right? So that is the importance we should have. We should have some kind of platform which can actually deal with agility. If it has to be fail, it has to fail quickly. Otherwise, I should not wait for over the weekend, right? Why it is failing, we can quickly fix it if we have the problem. Otherwise, we have to wait for a weekend and then come back with the solution. Then you're losing your time, right? So that kind of challenges still do exist with lots of organizations, but this is now going to be fixed by adopting this Hadoop kind of technology, right? So with the growing data sets, it's not only managing the data only, We have challenges with the finding the right information out of that data. That is also challenge. And for that, because earlier, if you go with we have a one, if you think about at least 10 years back, right? So we used to have a single node server where we are storing our data, and single node is having its own capacity, right? It is not actually able to store all data. Even if you manage to store data, but the processing time it is taking huge time, and you won't be able to even do processing of entire data. Probably you're doing your processing analysis on bit and pieces, and doing bit and pieces analysis, you're not ending up with the complete view of your data. So these kind of challenges we are facing with the growing size of the data, right? So this is one of the very famous quote in 1982, which was published by John Nesbitt, is the scientist, computer scientist. Is saying, I mean, he was saying we are drawing in the information, but they starving with the knowledge. That was the situation we had. Nowadays, though we have very much advanced, we have already using technology, but every organization is not using this technology. And even if you go with the lots of organizations, they don't care about the data, right? They don't care. They are just managing data for up to some extent for a year or 2 years. They have some policies in place. They're storing and backing up data. If it's 1 or 2 years, they're discarding all those data. But now trend has been changed. So that is what he's trying to say. We are drawing with the information, but starving for the knowledge, right? We have lots of information coming as part of data with the growing speed of the growing size of the data. Lots of information coming into, but we are not able to extract the knowledge out of that. What this data is talking about, because data is in a scattered and distributed manner. It's not easy to do. Single view of. It's not we were not having situation to have a single view of entire data, and we are not able to analyze entire data at a time. So probably we are doing analysis, we are breaking data into small pieces, then doing some analysis, then coming up with consolidated information. So that is what we had situation. In fact, even though we have the situation with lots of organizations. Right. So now, quick question, right? Since we are talking about this, we are drawing with the information, starting with the knowledge. So even though, as I said, if you go with the current organization and situations, every organization is not able to even extract the information out of the data they are generating. Maximum, I mean, mostly if you go with the government body, right? So now the government is very eager towards the digitalization. They are doing lots of things around the data. They are managing, they are exposing data, government's data. But earlier there was not situation, right? I have been one government engagement, right? I have been to we got opportunity to interact with one top leadership of the government officers. So she was being asked by PMO, please provide this kind of information. She was kind of desperate. I mean, she was not having complete information. PMO was asking for long 10 years, for 10-15 years back data. So she was not able to get the data out 10 to 15 years back. So entire data they were trying. So PMO is Modi's, guys, he's very active all these areas. He's very much he's playing. Even we don't play like he's playing with the data, and he's doing all presentations. Hey, so his office asked to that government sector, so they are looking for some kind of information on granular basis, but she was not having that kind of information. She was desperately looking for, please help us out to gather these information so that we can give it back to PMO. So that is the situation we have. The government, even private sector, if you go, that even this exists true with the private sector as well. Every private sector is not managing their information even within their organization's information very organized way, right? So what do you think, what percentage of enterprise data do firm use for analytics? What do you think about this? Right. So we have 3-4 responses so far. Yeah, so right. So absolutely correct. Even though in this scenario we have hardly, I mean, organizations, be it private or public, they are hardly using 12% of data for their analysis. So you can see there are huge scope for us to, to apply this big data kind of information, because there are lots of challenges with this utilization of the data sometimes. So they have the challenge with the storing, right? So they're not able to store, even though they are managing to store it, but they are not able to analyze in one go, right? So there are lots of challenges they are facing. That's why they are not utilizing entire data for their analytics perspective. It's hardly 12%. So probably it would be when we are getting even more 12%, even it's on higher side. So you can think about 8 to 12%. The utilization of this data is across the organization is 8 to 12%, right? So they are huge. But now, being private to public sector, everyone is very much concerned, and they are trying to manage. They are trying to store, manage, and trying to find out the information out of data they are generating, right? Even they are not trying to do any kind of analytics, they are storing data so that they can sell the data. So now data is like a gold mine for them. If you're generating good amount of data, it is having valid source of information, so you can sell it into market, you can get a good money out of that, right? So even without doing any kind of analytics, there are lots of organizations, they're expecting if you have valid data with right set of information, they are ready to pay any kind of price, right? So this is what we have. So as I said, I mean, we have huge scope in terms of big data and analytics, right? So utilizing the big data and analytics kind of technology across the industry, across the sector, right? So what are the top industries, what are the top domains they have somehow already started doing this kind of big data analytics, but you are not limited with this kind of scenario. You have you can, as I said, if your problem is qualifying all 4 V's, so you can say this is the big data problem, right? So you can apply your big data and analytics, but these are the top scenarios you can discuss about where big data is being used, or they are trying to adopt, or they are already using, right? So like, but if they are using the big data, and what perspective they are using, what kind of different use cases they are doing using the big data kind of analytics. So if you go with the web and e-tailing, right? So their recommendation engine, ad targeting, search quality, so using big data kind of analytics, now this e-commerce sites, right, they are able to do customized marketing means earlier what used to be, anyone is coming for the shopping, they are just shopping it, and whatever the standard promotion and offer, you're just popping up on your website. But now the standard promotion pop-up has been changed, it is being customized. I'm logging into Amazon, so I'm getting different kind of promotions on my page, right? If you're logging, right, you're getting different kind of promotions. How this is possible, and what is the logic behind this? What kind of analytics they are doing to come up with this kind of customized promotion or customized offering, right? So by doing this, they are trying to maximize their sales, right? Be it cross sales, sub sales, or they're trying to generate more revenue out of by promoting, by doing customized marketing and customized targeting of their, right? So their big data kind of technology is being very useful. So how it's being useful, if you go with this recommendation engine, if you log in on Amazon page, right? So moment you are adding something in your bucket or add to cart, right? So if you look at the bottom, this is recommended, probably people are buying this with this combinations, there are different kind of offer they're placing. So you can go with this, if you're buying this product, you can go with this product, people are buying this kind of combination, that is called market basket analysis, right? If you go with analytics perspective, That is, so these kind of different analytics they are doing. But how come this analytics is nothing but your statistical algorithm, but how you're applying, how this is going to be, this is not something, right? So speed, we talked about velocity, so we have to deal with the velocity of data as well. So velocity of data as a user, when we are logging into any websites, so in terms we are generating lots of data for the website. How the data, so if you're a programmer, if you're an application developer, you know, whenever you're clicking on any website, in terms of it is generating event, that event is getting logged inside the applications and web servers, right? That event is actually capturing all complete information. Who are you, what page you click, from which IP address you are logged in, what is your login details, what are the different pages you have been you have browsed, how many times you clicked, how many times you logged in on you are having session on a particular page. This kind of information is actually generating huge value for the e-commerce kind of organizations. And these by collecting this information, this is the real-time information getting generated, and at the end they are capturing those information, and by capturing they are real-time doing analytics, right? So by doing this analytic, they are real-time coming up with the some promotion. So it's not only, you know, so here speed is also matters lots. If you are able to reply, if your analysis, if you're agile enough, then you can convert, you can increase your sales, you can increase your revenue. Otherwise, so you are losing money probably as a Amazon. If I'm a Amazon, right? So as a user, I'm logging into Amazon, I'm staying for a few seconds. If something is not very attractive or something is not very much, you know, relating to my perception, my shopping pattern, so probably it would be little weird for me. I'll definitely switch to different website, probably Flipkart. Let's look at the Flipkart. So think about the point of time we are staying on that particular website. The point of time, if you have a technology there, these kind of Hadoop kind of technology is actually helping these organizations. If point of time you're able to do your analysis and coming up with the next best action, right, then you would be able to convert your prospective customer as a actual customer, right? So along with the size of our data or a different kind of data generating, so speed is also mattering with your analytics perspective as well. If you are able to reply within that point of time, then you would be materializing, you would be converting your prospective customer into actual customer. So there you can I mean blindly you can think about this kind of technology. Hadoop is the technology which is actually playing behind the role. So they are able to capture the data, they are able to do analytics, and it's not only analytics, it's not only analytics and capturing data, it's speed also matters, right? So speed is also one of the features. That's why we are learning, you know, Hadoop. So you can make your, you know, the same job we are talking about with my previous organization. This was the real huge case when we started as a Hadoop, as a POC. We had a very first huge case. So Hadoop as a, even it's, you say, I mean, it's not very much familiar with each and everyone. Everyone is just, you know, trying their hands with the Hadoop. Let's try with Hadoop. This is the new technology. But the very first perception across the organization is this is the problem we are actually struggling with data. Can you quickly execute in Hadoop technology? How fast we can actually execute this? So we had this exact similar kind of problem has been put across by the bosses. Hey, we had this kind of job is actually taking too much time. We know there is Hadoop, a new technology. Can we use Hadoop to quickly solve this problem? So can it quickly process my job, which is running 4-5 hours or over the weekend? So this one use case we have picked up as a as an adoption phase for the Hadoop, right? So we quickly migrated all data out of, RDBS, even some data was on cloud Amazon. So we have quickly migrated all data inside the Hadoop, and the job which was actually running over the weekend, we managed to finish in 4-5 hours, right? So that is the traction actually taken up. So bosses were very happy. Hey, it was very good. Let's start with the big bang, right? So that is the one value proposition. If you say value proposition perspective, the speed matters a lot, but it's not only speed. You have Hadoop is the platform which is actually supporting you variety of data. We'll talk in details what are the different features, what are the ways Hadoop is actually satisfying your requirement. So coming back to this scenario, so you can think about these are the few domains, be it e-commerce, telecommunication, BFSI, government sector, health and life sciences, retail. So this Hadoop kind of technology is perfectly helping these organizations to do their cross sells, upsells, or to ultimately to maximize their revenue, right? So you can think about these are the use cases. Even it's already being you just realize. I mean, you just try to remember these are the different use cases. Maybe if you are with this out of these organizations, if you're from telecommunication, if you're BFSI sector, if you're healthcare, you can try to relate what kind of use cases you can quickly convert into Hadoop. If your Hadoop is not being already used inside your organization, what kind of use cases you can pick up and relate and you can propose within your organization, right? So guys, so far we talked so much. Any questions you have?
In your previous slide, there was a term called visualization. So,
Yeah.
what is data visualization?
Okay, that's a good question. Any other questions we have?
Sir, you were talking about ETL. So what is that ETL means?
Okay, good question. So let me note it down quickly, right? So we have ETL, we have a data visualization, and
I'm asking about point of time data volume, like on very high. So are we dealing this kind of problem statement in big data also, or this is related with cloud computing?
So there's two things, right? So point of time, if your data is increasing, so nowadays if you go with the on-premise, there is a different value proposition with the cloud versus on-premise. On-premise versus cloud, right? So I'll discuss about what is the on-premise versus cloud when we are dealing with the data. So I'm also responsible for dealing with the cloud. Cloud across the India sector, so we can quickly talk about. But your question is point of time size of data, or maybe you can say so we have a trend, let's say every 30th of the month, right? 30th day of the month, we have huge volume of the data, right? How we are dealing with this kind of problem, right? So can we solve this kind of problem with the Hadoop?
First
right?
of all, if this is related with Hadoop or if related, then
right. I'll discuss in that perspective as well, right? So now let's first quickly talk about any other questions we have.
So is there any minimum amount of data that is to be considered as big data?
I think this is, you cannot say a minimum amount. See, if you talk about, right, there is no standard formula we have so far. Is there any minimum? a standard formula you can define. If its size of data is like this, then you can convert it as a big data. So probably, let's take an example. If we have a 10 gig of data, right? So 10 gig of data, or maybe 100 gig of data, which data you can treat as a big data problem, right? So maybe 100 gig is quite high. Maybe we can say, 50 gig of data, right? Can we treat this 50 gig of data as a big data problem? Or 10 gig of data as a big data problem? Is what 10 gig having? If it's structured data, right? If it's structured data, and you're not bothered about, the speed or agility with the data analysis,
No, sir,
right?
just the volume. Yes, sir, just the volume. What is the minimum volume? Is this any kind of criteria there?
No, I'll say there is no as such criteria with the size of volume, right? So you can think about, I mean, probably your if you go with your RDBMS technology, RDBMS technology, if you have a good cluster size, right, you have 100 gig of data, even 100 gig of data you have, you can process it. You really don't require big data as a technology to process it. Why? Because I'm not concerned about my, speed of data. I have executed my ETL jobs. It's running for a very, speed. Whenever it's get executed, it's get executed, and then I'm getting result. So I can live with even non-big data kind of technology, right? But even 10 gig of data you have, even 10 gig of data you can think about this can be a big data problem, because it is having variety of data, and you want data to be analyzed in a very fast manner, right? Agility is very important nowadays. You cannot live with the, your job is running for a long time, because by the time your job is coming up with the answer, your opportunity to materialize it, your opportunity to convert into dollar value is gone already. So agility and speed is also very important. Even 10 gig of data can be converted as a big data problem.
So even this is good with the big data thing. Even with smaller chunks of data, this is completely suitable.
So as I said, now you have to think about what is the requirement, what's the business case. A smaller chunk of data, if you really wanted to make it a very fast manner, to be analyzed in a very fast manner, so you need big data kind of platform to get it analyzed,
Other
right?
than the processing speed, everything remains the same, right? It can handle the big data and the smaller chunks of data as well.
Exactly.
In that case, if we want to create a super set, so if I'm implementing any kind of database management system or organization, and I think that for now I have structured data. Volume is also very low, but if I implement Hadoop, so in future I can implement a Hadoop features also in this. So is this good decision for the organization if they are implementing without requirement of Hadoop and investing in that for keeping the things of future in mind? It's valuable for them.
So you mean, I think I didn't get your question. So you mean you're going with the distant perspective, you're going with the RDBMS technology, and considering your future requirement, you want to migrate into Hadoop. Is that your question?
So beforehand we are implementing Hadoop.
Mm-hmm.
So there will be some cost.
Mm-hmm.
Is to stop making a simple RDBMS system or Hadoop. So
Mm-hmm.
we are investing in Hadoop, and we think that now we will get the value in future.
Mm-hmm.
So rather going for the first place with Hadoop or migrating on Hadoop, which one is better?
I think you should definitely go with the see. You should definitely go with the Hadoop kind of technology. So it's strategic. What is the objective? What is the long term goal of your this kind of use case. If you are thinking you're kind of trying to solve this problem, probably over the period your data is growing, probably over the period you're trying to have a consolidated view of your data and you're collecting data from various sources, then what you have to think about, I'll discuss in details in following slides we have, so where you'll identify where it is actually going to perfectly fit which kind of technology. But out of curiosity, so now your situation, you can think about, you have some application which is doing some transaction management, right? Which is doing some transaction management. To suffice that transaction management kind of activity with your application, you need RDBMS technology. So you cannot, then in that situation, you cannot absolutely replace your RDBMS with Hadoop. You have to live with Hadoop, right? You have to live with the RDBMS. You have to live, if it's transaction management, you have to live with Hadoop. Sorry, other way around. You have to live with the RDBMS. Right.
On top of that, we should not do
Exactly. I'll discuss about the architecture perspective. There's slides how the Hadoop is fitting into your existing this RDBMS warehouse RDBMS structure, right?
It means Hadoop is not superset of RDBMS.
You cannot say. You cannot say. You cannot say absolutely. RDBMS having its own value proposition. So transaction management, you know what is the transaction management? So like if we are doing some banking kind of, if we have some application which is satisfying banking, where you're doing transaction management is having some features, right? So what is the feature is all about? Whether transaction is going to completely successful or whether it is going to be fail, right? So mostly if you go with the banking organization, all applications which is actually dealing with the financial transactions, so then there you cannot adopt Hadoop at all. You have to live with this RDBMS technology, right? But over the period, you have, let's take an example. You have a 100 like this application, 100 application which is using RDBMS kind of technology, and they're distributed in sectors, right? They are distributed in different machine, but they are distributed. Now you want to have analyzed, or you want to collect, you want to store all data in one place, and to get it analyzed, right, holistically in one go, then you need Hadoop kind of technology.
Basically, if you look at organization structures also,
Mm-hmm.
we have this RDBMS into distributed, it's a kind of distributed system.
Correct.
Right? Just for extraction purpose on this RDBMS also, we think that we can consolidate this on just one cluster, I mean, a node or something, and then we can use this.
Correct.
Other than that, we have to just, other than that, on RDBMS, I mean, SQL based thing, we cannot use this thing.
Right.
For this, the database requirement is always NoSQL based, I mean, non-RDBMS for Hadoop.
Not exactly. So if you go with the analytics, right, analysis, whenever you want to do analysis, you have a data in some different format. Whenever you're going with the analysis, you cannot do analysis without bringing your data in some structured format. So when you have to bring your data in a structured format, then you have, even though you're using Hadoop, data size is big, you have to bring in some structured format. Then there is concept of RDBMS, not completely, but it is going to apply there, right? So we have interesting discussion around these topics in following slides. We'll discuss in detail. But yeah, so you definitely need to bring your data in some structured format before doing any analysis. In a Hadoop ecosystem, your data is nothing but it's saying your data is unstructured, any kind of format. Even if format is different, we have to bring data in some structured format to do analysis. There is Hadoop actually helping us to even bring data into structured format. Right. So now next question we have with what is ETL, right? ETL Now ETL, and you can say there is also ELT, right? ETL stands for extraction, transformation, and loading, right? When we are doing any kind of data warehouse and analytics perspective, whenever the data, being data scientist, when we are working, when we are applying our models, right? When we are doing some analytics on top of data, before the doing analytics on data, data is coming up, data is passing through lots of phases, various phases. What are the phases? You're collecting data, you're cleansing data, you're mining data, you're bringing into some normal format, then you are doing analysis, right? So then collecting, mining, cleansing, and bringing into some format is called the process of ETL. Extraction, transformation, and loading. So extracted some data and then you transform it. Why you transform it? Because you have to bring your data in some required format so that you can do analysis. You cannot upfront, you got the data, you can do, you're doing analysis. Before doing analysis, before applying your statistical technique, you have to bring your data into some format, some logical format that model can be applied. So this, before doing analysis, all the steps what we are doing, that is called ETL. So ETL means bringing data into some standard format which can be used for analysis perspective. Now there is concept of ELT it's being talked about. So that is again extraction, loading, and then transformation. When we are discussing about Hadoop technology, then people are using ELT rather than doing ETL. They are using ELT. Why ELT? So Hadoop we say, so in this ETL process, we are extracting, transforming, and then loading into some RDBMS or some system, so where where analysis can be done, right? But before loading into some database or some RDBMS system, I'm doing all transformation, right? So if my data is huge, so transformation on normal system or database is not easy. So what we are doing, we are extracting and loading into Hadoop. Once data inside the Hadoop, then Hadoop is platform to do any kind of data processing, any size of data. It can help you to do any size of data to be processed, right? Then we are doing transformation there. So there in Hadoop sense, if we are doing all this ETL kind of, so it is converted as ELT. ELT means we are collecting data and directly loading into Hadoop. Once it's loaded into Hadoop, then we are doing all processing and mining, cleansing activities inside the Hadoop. That is called transformation. Is that clear? Now you have another question. What is data visualization, right? So data visualization. So that is the whenever we are doing any data analysis, data processing analysis, right? So this is the last step of data visualization. There are various steps. I'm going to talk about what are the different phases you have to go through when you are doing data analysis. The data visualization is the last phase. Data visualization. So visualization means I'm trying to present my data in some graphical manners. We know a picture tells a story of 1,000 words, right? A picture can better tell the story of 1,000 words. If I have some data in Excel format, so rather than sending that data to end user, so end user has to look inside the data. If he's technical enough, then he can understand what is the various data is talking about. But if it's not technical enough, it's business user, how you can better present how quick your data so that he can quickly understand what is talking about, right? So for presenting your data in a normal raw format or Excel or some table and column, row and column format, it's better present in some graphical manner. Using graphical means you can use chart, you can use some graphs. So by looking into graph, one can easily understand, right? What this trend, what is this graph is talking about. So that is called last step. That is called data visualization. And data visualization is art. Though you're doing analytics, but it's called art. Art means why it's called art. So there, you're all. You have to put your empathy. You have to put your story. You have to put in a such a way it can be easily adopted. That is the last interface which is being used by business user. If business user who is actually paying you money for doing your job, if they are not able to understand what you have done, whatever you have done, be it whether you have utilized mainframe, Hadoop, any kind of technology you have utilized does not mean to him, right? What it mean to him, he is able to relate the sense, to make some sense out of looking into that chart, right? So that's why last stage, which is visualization stage, is called, it's though it's a pure technical word, but it's called as art. It's not a technology, it's not a science, it's called art.
Is predictive modeling same as?
Yeah, I'll come to, it's too early, I understand. I'll discuss about all these, what are the different stages, what are the different analytics you can do that, right? So just wait for some time. It's
Hi, Bhupender.
yes.
Hi, this is Rajkamal. The thing you explained about data visualization, so I have a question about it. What is the difference between the exploratory analysis and data visualization then?
Right. So, Rajkamal, exploratory analysis, there is different phases of analysis. Now, analysis and visualization is altogether, you can say, different things, right? Visualization means you are presenting your data in some visual form. But before presenting, you're doing all analysis. Before presenting your data, you're doing all analysis. So analysis
Okay.
can be your exploratory analysis can be your historical analysis can be your predictive analysis can be your prescriptive analytics, right? There are different ways of analysis. So after doing these analysis, then visualization coming into picture. Is that clear, Rajkama?
Yeah.
Right.
If nothing data is visualizing, then what will be better, Hadoop or RDBMS?
That's a good question. Why we have so much? Guys, please mute yourself if not speaking out. So we have a background noise. All right. So for the data security perspective, so it is always security is the feature which is actually definitely very powerful in if you go with the RDBMS. Why they are very powerful? They are since ages into the market, right? It's being used across organizations for all critical applications. But even in Hadoop world, now data security has been also implemented, and they are providing all necessary security which you really can find in RDBMS kind of technology. I recently completed one security project with Malaysian bank. That I have implemented big data security in the big data, right? Complete end-to-end security. End-to-end security means your data is you're getting authenticated with the high-end authentication mechanism. That is the Kerberos authentication. Your data is actually being managed proper authorization. There is one Hadoop technology which is called Sentry. So you can even control which table one should access, which table one should not access. Even column level control, you can do that. And there I have implemented encryption as well. So data, you can encrypt your data, and if it's encrypted, even if you got the data, you cannot do any. It's waste of data for you. You cannot do anything. You cannot read it data unless you don't have associated keys available with you. It's a very interesting project. So as in the last class we talked about, if time permits over the class, I'll share that experience. Really interesting. So when Visa kind of organization, which is pure financial and critical organization doing all critical data processing, they have adopted Hadoop for all this critical data processing, and they have certified Cloudera. They have adopted Cloudera. So they have certified the Cloudera as a pure secured environment. Though it's not Cloudera, you can go with the Horton. Horton is also having similar kind of features, but they have adopted Cloudera and they have implemented all security features, and they have certified this environment as a secured environment for your data, right? So you can go with the Hadoop. Data is also secured there. Okay, shall I move?
I have a question.
Yes, please.
Like we are learning big data analytics as well, right? So my question is just for my curiosity. How much in terms of volume the data we are going to have in practical example?
So practical example data would range from MBs, megabytes data, maybe sometimes gigabytes of data, because it's depend on kind of systems you have. We are doing all practice on a single standalone. Even we are struggling with the installing. So it's depend on I can share with the size of data, but as of now, as I said, we are dealing with MBs of data, not even GBs of data, because we don't have powerful systems available with us.
We cannot try it for multi-node as well as dealing with terabytes of data or exabyte.
No, because we don't have infrastructure available, right? We should have infrastructure available, then you can deal with. So irrespective of data does not matter, right? Irrespective of data, if you manage to do the small amount of data to process with the Hadoop data, Hadoop kind of technology we are going to use, then you can process any size of data, right? So as long as we are growing with the data, we can increase, we can scale our cluster size, we can scale capacity of our cluster as well, node as well, right?
Okay, so if I want to do practice the same thing which we're gonna do for MBs, right? I want to do for TB or EB. Then will you be provide support for that? What are the things I required from my side?
Yeah, definitely. Feel free to reach out me, any size of data, right? How you can do that, how you can deal with, right? But as a user perspective, you're not going to this is not going to make any kind of changes for you. If you have written some program to process 10 MB of data and it's working properly, you can execute same program in 10 terabyte of data without any issue. And you don't really have to do extra things. You really don't have to do extra things. Even if you have written a small program to process your 10 MB of data, so the same program can process your 10 terabytes of 10 petabytes of data. And the process wise, the steps wise, it is not going to make any kind of difference to you. Whatever you do with the 10 MB of data, it is absolutely exactly same with the 10 petabytes of data, right? It just, the size of data is growing. You just have to somehow import into Hadoop cluster. If you are importing 10 MB of data in Hadoop cluster, then you can import 10 petabytes of data. Clear?
Yeah, thank you. One more question. Our course, hello?
Yes.
A course is designed in such a way that this is for my curiosity only again. A course is designed in such a way that we will be, able to go for the Cloudera or Hortonworks certification for big data.
So yeah, you can attempt Cloudera and Horton certification, but as I said, I mean, most of the topic, it is almost 60 to 70% it will cover. But for certification perspective, you have to actually look into the syllabus, and you have to do some self study around 10 to 20 or 30%, right? And if you're comfortable with what we are going, you can easily adopt 30. You can easily scale your learning with the 30%. It is not going to beyond that your learning.
Thank you.
Right?
Bhupendra, I have a question. Can you please highlight the difference what we are doing right now in our standalone system, and if we are going for a company as a big data analyst, so what are the changes we are going to experience system perspective wise?
Yeah, I'll discuss in detail. An architecture perspective, I'll discuss in detail.
Okay.
No need to worry. We have a detailed discussion around that. Any other question you have?
I think that can be covered in architecture.
Yeah.
Difference in volume of
Definitely. We'll have a detailed discussion architecture perspective where I'll try to clarify, clear out if you go with the standalone, if you go with the cluster, how it is actually, though, as I said, it is not going to make any big difference for your perspective as a user perspective. But if you're administrator, then definitely it makes sense. It makes sense, right? But user perspective, it does not make any difference for you. It will look exactly same. But even administrator perspective, whatever the architecture I'm going to cover, it is help you 90%, right? Clear? Shall I move? All right, so this is where we were, right? So we are discussing about different use cases, different scenario where big data can be applied, right? If you look at here, healthcare and science, right? So look at the recent article. If you have followed the Modi visit to Israel, right? Israel president was talking about, he was emphasizing, right? Uh, they were, in fact, we know Israel is very good in technology. They have less population, but what they are trying to do, and they are trying to apply analytics in healthcare. They are already applying, but what they are next level, what they are trying to do for each and every citizens, they are going to have a customized prescription drug, customized drug. Now, when we go into market, we have a generic drugs, right? If doctor has prescribed it, we have to live with. But analytics is moving in healthcare. It is going to have, even like we talked about in e-commerce, right? We have a customized marketing. It's one, it's this, they are targeting one-to-one based on the different perception, interest, and like, you're getting different kind of advertisement. In the same way, analytics is being used in healthcare, where they're trying to have, they're collecting each and individual's information, they're storing, they're curating, and they're generating some specific drug for specific individuals. That is where Modi is also trying to do uh, something here. But try to relate why I'm referring that visit, right? Because in healthcare sciences, analytics is already being used, but it's reaching up to customized drugs prescription, right? So now goes, if we are getting into market, we have some pain. So for painkiller, we are taking any kind of painkiller which is generic, but over the period we'll realize what kind of pains we have. So probably our composition of the medicine is going to differ with the others. It's not going to be standard Disprin or Crocin or maybe some Hapenic kind of painkiller tablets, right? It is going to be customized drugs. So these are the different fields. If you look at the telecommunication, so we have a very good use case. If you're moving from one region to different region, you started getting different offer and promotions. Your roaming is free. You can buy, if you are traveling international, by the time you're getting boarded, getting landed, you're started getting different kind of offer. Welcome to Malaysia, you can switch to our network, and you can avail this kind of discount. You can we have this kind of data available. So different kind of, from how this is possible, because that point of time is very important for those organizations to convert you into prospective customer into right customer, actual customer. Then they can increase their sales revenue. If they are not able to maintain that pace, agility, they are not able to maximize their revenue or sales, right? Their big data and analytics is playing huge role, right? They are providing, they are enabling these organizations, Hadoop kind of platform, enabling these organizations to come up with this kind of offer and promotion specific to particular persons with a very fast manner. Because speed is very, very important, right? If particular time, and let's take an example of retail store. Now, in retail store, right? Even in retail store, if you're going for the shopping and all, right? So moment you are around the retail store, there is very good use case around the IoT in retail store, right? Moment you are around the retail store, there are lots of IoT devices sensing you. They're sensing you. They're IoT devices. There can be sensor. There can be camera. There can be some GPS tracker and all. It's installed their retail store, and every time they're monitoring their customer, right? By monitoring customer, by using so one of the use case uh, we're actually pursuing. So there we have the visual sensors applied. Visual sensors we have to install. So visual sensors, what it will do, it will actually capture your image, and based on the image analytics, right? There is advanced analytics, machine learning algorithm is going to play. So machine learning algorithm, it's too early for you guys. I'll discuss in detail what is this all about. But for out of curiosity, just we are talking about the use case, how it is going to play a role, right? So this visual sensor, they are capturing your pictures. Moment you're even passing with the retail store, and for the time being, you just stand, even for a second, you stand in front of the retail store, you started watching some products, right? Your image is getting captured, and by the time image is getting captured, it is getting analyzed. Who are you? And probably by analyzing you using the machine learning algorithm, advanced analytics and deep learning algorithm, they're trying to quickly come back with who are you, what kind of profile, who, either you're male, female, what is your age, what is your like, dislike, what is your reaction by looking at those products. And then they are coming up after doing all this analysis, after capturing this features out of this image, they are doing analysis, and then after coming analysis, they are coming up with the some promotion, some offer. They are trying to attract you with the different kind of, even they have a smart screen, even they have a smart glasses installed outside of the store. By analyzing your image, they're real time, they're popping up some offer in front of the smart glasses, a smart screen, which is ported outside of the retail store, so that they can attract you as a customer inside the store. Once you are inside the store, then you can be converted as an actual customer. So these kind of analytics being used, and this is possible only with this kind of technology. So you can think about this big data and Hadoop is going to fit almost across all industries, right? But you have to think about other perspective as well, right? If really concerned about the speed, agility, or variety, then you can replace it. Otherwise, your legacy database can work. I mean, if you're a small store, you don't worry about, you just wanted to do historical analysis, you just wanted to look into what this data is talking about, you want to do your monthly analysis, right? What we have done as a retail store for over the month. So this kind of analysis you can even do with your legacy databases and systems, right? So moving to the architecture perspective, how it is fitting into, how Hadoop is fitting into. This is your legacy. If we talk about data architecture analysis perspective, or data storing or managing perspective, this is your legacy data architecture or data warehouse, you can say, right? So how it looks, this is the various sources of information or various applications, you can say, which is actually connected with some RDBMS kind of database, and your database is actually your data, you're managing your data. Some data you're managing in even management. I mean, RDBMS technology, normal technology, you're managing data in different ways. Some data is hot data, cold data, in-memory data. What is hot data? What is cold data? What is, so logically you design your data even in RDBMS. In RDBMS system, how logically you design your data, you convert, you name it as a hot data, or maybe you name it as a cold data, or maybe, and you store even inside the in-memory data. But what we call hot data, what we call cold data. Hot data is those data which is being accessed, frequently. It's being used frequently, right? So you can convert it as a hot data. So probably you can put it in, very fast disk or place, right? So you can easily, optimize, get the right performance. The cold data, which is you're really don't, you just stored it, you're not using, you're just whenever required you're using it, right? It's not using frequently. You can store it somewhere in backup tape or some low performance disk, right? Then you can categorize as a cold data. In memory data, for example, I'm doing some fast analysis, right? So fast analysis, for doing some fast analysis or or transaction, I need data should be available. IO of the data should be very fast. How IO of the data we can make it fast? So we can store inside the memory. If it's inside the memory, then interacting with the data would be very, very fast, right? So that's where we actually look into what kind of data we should put inside the memory. And then this is your ETL system, and after doing all this data messaging, data transformation or ETL, then you have the in analytics system. So this is your traditional architecture we are following so far, right? So you have your application, you can say at the downstream you have maybe you can say it's upstream you have application is connected with some database, and data you have collected some data by those applications, and then you're doing some analysis. This is normal standard architecture we have, right? So if you go with the organization, if you're fresher or new, so you'll find this kind of architecture. Probably if you get a chance to get aware about your data center, your data architecture, so you'll find similar kind of architecture. You have application, you have database, those are connected, and then you have a third layer for analysis. Whatever the data you have collected, you are doing some internal analysis, right? So these are the three layer of data architecture you'll find. But how Hadoop fitting into this architecture now? So this is right? So how Hadoop is fitting into this architecture? Now, this is where you can actually fit your Hadoop in the middle layer, where you have your data, or where you have your all ETL kind of jobs you are doing, where you're managing your data, right? So best use case with the fair. So your Hadoop can coexist with your existing architecture, right? Your Hadoop can coexist with your Hadoop existing architecture, and it is good practice. You should not directly go with only RDBMS, or you should not go directly with the only Hadoop type kind of architecture. This is one of the best architecture you can say, right? So you are staying with the RDBMS and Hadoop kind of architecture simultaneously with the same infrastructure, right? So how it is helping us with this kind of architecture? So if we have, let's take an example, if you have huge data. Now the situation, I have my data size has been grown, right? My RDBMS system is not able to scale up. Even RDBMS has its limitations, right? If you can go with the RAC, Oracle is having highest, RAC cluster, right? Even if you go with the RAC, it has its limitation. You cannot scale beyond that cluster size, right? Even you go with the MS SQL, you cannot scale beyond the cluster size. There is some limitations, and after that limitation, even OS and hardware is failing. They will not respond properly, right? So in that situation, if your data size has been grown, you can lift your data to Hadoop. You ask whatever the big data we have, Hadoop will lift and do all necessary processing. So why we have, see, what is the situation? First, we'll try to understand why we are fitting into Hadoop. Now my data size has been grown. Now my RDBMS technology, it's able to do, but it's taking too much time. It's giving so much load on the system, and even by using the same infrastructure, my rest of the application is impacting. because I have loaded huge amount of data, and all processing power is being utilized by huge data sets, and the same database is connected with your upstream applications. You have performance impact on your application, and if it's business critical application, you cannot live with this performance issue, right? So what we can do, we can plug our Hadoop, whatever the big data we have, so we can dump into Hadoop, right? But first we think why we are actually, though there is situation, so though there is situation, right? So we can store the huge amount of data in RDBase, but when we are doing some processing, why we are doing processing? To get some information, right? To get some output so that it can be consumed by another application or can be used for analysis perspective, right? So moment it is doing processing, it is utilizing all power of the existing my RDBMS cluster. Then as I said, it will impact your upstream or downstream application, because you have your processing is being utilized by your data, huge data you have ingested into your Hadoop cluster. So what I can say, I'll lift my all data and I'll port into Hadoop cluster. I'll ask, this is my data, you process it. After processing, whatever the output we need, will dumping back into RDBMS. Because there are sometimes we have the requirement, our applications is actually only can live with the RDBMS technology. If it's transaction management, if it's doing some different kind of job, or my application is designed in such a way it can live with only RDBMS, right? So there could be situation after doing analysis, I need the data back into RDBMS systems so that the data can be further used by my application. So here, by offloading all processing we were doing here, we have offloaded to Hadoop. So my existing database is not being impacted with the performance. My application is not being impacted with the performance. At the same time, I'm doing my necessary processing by utilizing Hadoop, even in a very fast manner. And once analysis has been done, analysis means after analysis, we generate some data, right? Once data has been generated, I'm sending back it to RDBMS, and then it is being consumed by your downstream application or some analytics dashboard, right? This is how one use case you can quickly fit into.
I have a question here.
Yes, please.
So, see, you said that we are having some limitations with RDBMS. That's why we have used
We
Hadoop.
are losing your voice, please.
Hello?
Yes,
Hello?
please. Yeah,
Yeah.
please.
So just now you said that we have some limitations in RDBMS. So that's why we have used Hadoop to deal with the data, right? Okay.
Sorry, come up again. I was a little distracted with this. Is okay.
So
Please.
you said that we have some limitations with RDBMS. So we use Hadoop, right, to deal with the data. So now you're saying that after processing the data, we can, use RDBMS again. So I mean, I'm not getting the fact that when RDBMS is not capable of handling that much volume of data, then why are we using it again after processing the data in Hadoop?
Okay, that's a good question. I think I tried to explain. So let's take an example. You have some application, right? Let's take an example, this CRM application or ERP application you have, right? This CRM application, or ERP application is having some reporting dashboard or some kind of an reporting it's doing, right? For reporting, it has to analyze some data, right? If data sets is used, then you can offload this data to RDBMS. You can offload this data to Hadoop, and Hadoop has done processing, and whatever the analysis it has done after generating data, you can import back into RDBMS. But the situation why we are importing back into RDBMS, because my downstream application is actually can consume data only from RDBMS. my downstream application is designed in such a way which can actually consume data only from RDBMS, right?
Okay, so is
In
there
that
any?
situation,
Okay, okay, all right. Okay.
so there could be situation. Let's take a banking data, right? Banking application.
Okay.
Now,
so like in ICICI Bank, they are giving last 3 months statement or data ready for user. If they want data before 3 months, they need to click on different option, and after that they are providing information. So in kind of hot data, they are keeping 3 months data, and all the data, previous data, they are keeping in backend. And after processing that data, if required, they are again putting into system so they can publish or give the report.
right. So this is one example. Even you can live in your example, you can even live with your RDBMS technology, right? But why we have this Hadoop requirement? You have your RDBMS. All banking applications have RDBMS as a database. They cannot live without the RDBMS. Are you agree with my this point, this thought process? They cannot live, right?
Okay.
Now let's think about the situation of now banking is also moving into real-time transaction. Banking is also moving into real-time transaction. In earlier scenario, even if you go with the statement, you can get, as you said, 3 months data statement quickly. Just download it, click it, and you have the reports generated. That is again analysis, right? One report, one dashboard. But if you need more than 3 months, probably you have to file manual request. You go visit to branch office, then you will get more than 3 months data over the email by extracting. So from where they're extracting from backup or some cold storage, which can be again your RDBMS, right? Which can be again your RDBMS. Now think about the situation. I need the same interface where I can generate my statement at any point of time. At any point of time. So, but so what we in this situation, what we can, I have here is my banking application. By using interface, I have given instruction. Please download last 5 years statement, right? So your request will go to database. Since there is you have used right filter, it will check my data is not available here. It will move request here. It will collect all data what you have instructed, and then after collecting data from here, data will come back here, and then it will be visible to you here, right? Here you can put, and this can be your real time. This even you can make it real time. Earlier, what we so far even we have seen, but if you go with the Western banks, they have already adopted. You can generate your real time data. You can request your last 5 and older transaction on a real time basis. You don't really have to visit the bank, right? So my point is here, there are some applications which actually can live only with the RDBMS technology, right? So that's why after doing analysis, I have to put back data into RDBMS. If I'm not putting back, then this application will not able to consume it. Does that make sense to you? I don't know who was asking. What is your name? Online.
Yeah, that's fine. I get it.
Okay, right. So far we are clear. Any further question before we go for the break?
The previous question which I asked regarding the different point of time or data handling capability. So how cloud is fitting into this picture, like paper uses or how we are tracking?
So you have one question which is actually on cloud perspective, right? Cloud perspective. How you can utilize every organization now moving from on-premise to cloud. So banking, I mean, there's some critical financial organizations, they are little concerned about moving data into cloud because they're not very much, confident with the security of data on cloud, because if it's hosted in cloud, so it's not in your control, right? It's controlled with the third party cloud cloud provider, right? And you never know whether cloud provider is actually reliable, though they are proper agreements, everything is placed, but you cannot trust at all. So that's why BFSI sector is little concerned moving with the cloud. But rest of the organization, even BFI sector, there are lots of their organization is trying to not going with the public cloud, they're trying to use the private cloud. There's two type of cloud model. Private cloud means you can have your cloud on your data center, or you have a cloud even in public domain, which is properly fenced only for you, right? So now let's take an example of ETL, right? ETL, I'm doing my ETL, right? So I have ETL means why ETL? I think now you're clear why we need ETL. Before doing analysis, I have to prepare my data. That is part of ETL job. So ETL used to run for a long time if your data depend on the size of data. But I know at the end of month, right? At the end of month, I need there's some reports to be generated at the end of month. Reports to be generated, usually financial reports to be generated at the end of month. If your organization is big, you are processing huge amount of data, right? So only at the end of month you may need heavy processing. You're doing heavy processing. You're doing only one day, you are doing heavy processing, but this one day is very critical for you, right? So let's take an example. I have a cluster of 5 node, 5 machine. Maybe don't relate with the node. Maybe I have a system which is having 50 gig of RAM. 50 gig of RAM. I have one database which is having 50 gig of RAM and maybe 32 core, right? This is size I have. This is normal standard size I have. I'm processing my data, but at the end I'm processing huge amount of data, which is actually with this size it is taking maybe 6 hours. It is taking 6 hours, and after processing 6 hours, then you are getting result after 6 hours. And sometimes it may happen your data is actually not processed. There are some bugs, some network latency, some problem has arisen, and your job has broken, right? So then you have to again initiate you, and you have to wait for 6 hours, right? But I need this 6 hours is very critical, because after the end of 6 hours, my boss is expecting some data, and they have to report it back to client or maybe internal, right? Is this at monthly in financial organization, this month end ETLs are very, very critical, right? So what we can do if you're in on-premise, right? If you're in on-premise, so you have a restricted set of information. You cannot grow your cluster size, right? Either you can this is heavy processing. I wanted to optimize it one hour. So what I can do, I can add 50 gig of RAM more, right? 50 gig of RAM more. I can add I can add 50 gig of RAM, and I can add 32 core of CPU. I can add, and I can optimize. But so cost of increasing this is quite high, and you are just using this much infrastructure for one day. You are using this much of infrastructure for one day, but you are upfront you are investing lots of money to increase your system's capacity. But when you go with the cloud is having elastic concept, right? Elasticity. So there is point of time you can grow capacity of your cluster, and once you require the heavy processing, you can increase the capacity of your cluster, and once you're done with your processing, you can reduce the capacity of your cluster. And by the time you have used the capacity, you're paying that amount of money, right? So that is where the cloud is actually having a value proposition, you say. So you upfront, you are not investing so much money on your infrastructure, right? You're not investing so much money on infrastructure. Whenever you need, at any point of time, without just a single click, you have necessary resources available, and you are paying, rather than paying upfront 50 GB core, 32 core of money upfront, you're paying probably for 1 hours, right? 1 hours, 1 hours, whatever the resources you have utilized, you're paying for 1 hours, right? So there you can relate with the on-premise and cloud. What is the value proposition with the on-premise and cloud? If you're going with the on-premise, probably you have to, that is where the concept of capex and opex, right? Capital expenditure and operational expenditure. Capex, if you're going with the operation, going with the on-premise, you have to invest upfront capital, you have to invest huge money. But if you're cloud, you can go with the single machine, 1, 2 core, 3 core, and at the end of a month, when you need, your job is going to be processed, heavy lifting is going to be done, you can quickly increase the size of cluster, and you just have to pay a few dollars, and once you're done with, you reduce the size of your cluster and live with the normal size of cluster, right? So that is where we have the cloud and on-premise value proposition. Other than that, there is no difference as such.
So there is no difference in our processing logics or not doing Hadoop analysis. Same logic will be
even
for cloud.
Even if you're going with the cloud, right? So even you have the Hadoop cluster. Let's take an example of Hadoop cluster on-premise and cloud, right? On-premise, if you have a again, in on-premise case, you have upfront invest all infrastructure. But if you're going with the cloud, what do you have to do? You're not doing heavy lifting every day, right? You're not doing heavy lifting every day. So when you need heavy processing, you can quickly increase the size of your cluster and do your processing and then reduce the size. You can live with even 2-node, 1-node cluster, 2-node, 3-node cluster. Minimum cluster size, if you go with the cloud, 3-node cluster. You can go with the 3-node cluster, you just pay nominal fees. You're doing your normal job. But when you think you have a heavy lifting, big data you have to be processed, you can increase point of time 30 nodes cluster, right? So that is the difference between on-premise and cloud. I think we are talking for a long time. It's been 2 hours more. You need a break, right? And I do, right? Let's have a 15 minutes break, and then we'll regroup, and then we'll resume with the topic. Okay, right, guys? Let's have a 15 minutes break. Right. So this is where we were. Right. We were discussing about saying. Okay. Right. I hope this. So far, this architecture, are you convinced how we can fit into this your legacy architecture? How you can fit in your Hadoop, right? So it's just one example. It's just one example. We talked about heavy lifting, right? There could be one situation, right? You have RDBMS data coming from here, but you wanted to relate your RDBMS data with some social data or unstructured data. Nowadays, if you go with HR analytics is heavily utilizing this architecture. What they are doing, they're trying to predict the churn of employee. How fast, when particular employee is going to be churn out or resign, right? How they can predict? They have the internal information for employee. They are trying to relate your internal information with social information. If you are really looking opportunity outside, you must be talking to your friend with WhatsApp, you must be browsing some job sites, you're updating your LinkedIn profile, blah, 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 right? So by collecting all those information, they're trying to relate with the profile, whether you're the employer, their employee, which is actually doing this kind of activity outside of the organization. And then they were trying to relate, and then they are coming up with some predictions when you're going to leave the organization. If you're a critical resource, probably they will try to do some counter offer or proactive offer. Maybe they can promote you quickly before you're putting your paper, before you started actually looking outside. so that they can retain. This is kind of, even in HR analytics, people analytics, it's being useful. So how this Hadoop platform is useful? Because my internal information is in structured format. Employee data is in a structured format, but I need some social data which is unstructured. This platform is not good for that analysis, right? So I can collect social data here, which is unstructured in Hadoop. I can pull my structured data here. I can correlate. I can do join operations so that for my particular employee, I can extract related information from social media and then can come up with some predictions, right? That is the second situation you can scenario. You have so other scenario, you can have a 360-degree view of the data. Customer 360-degree, one of the very good use case being talked across any industry. Customer 360-degree, what does it mean? I hope I'm recording. Okay. Customer 360-degree means I just want not only the information I have, even by collecting info various phases of my customer information, I'm collecting and then doing some analysis and then trying to find out the right opportunity for the business with my new customer or existing customer. I've done one use case with the automobile sector. Their automobile company actually trying to find out, they're trying to build some customized marketing and a special campaign for their existing user, right? So they have existing users data sets in RDBS format, and they started collecting social media, various social media's data, and they were trying to actually identify what my customer is currently doing. Maybe they have they have not collected birthday information, but they wanted to make a very personalized attraction or relation with the customer, so they got the birthday information from social media. So probably they have sent some birthday greetings, right? So that is one way you are trying to make some connection with your customer. Another use case, you're my existing customer, you have bought one car, I have some information as a part of buying car, you filled some form, I have collected some information, and even your vehicle is going for service, right? In my service center, from there I'm collecting my data. Now over the period, you started looking for second car, right? Maybe for your family, maybe for your parents, right? You'll start looking for second car. So since if I'm not aware about, maybe I'm not aware about what my customer is doing, what exactly he's doing, right? So I would not be able to actually attract, maybe let's take another way. I have the automobile company has a data with some information, but over the period he started looking about new car. Now he want to pursue and buy new car, so he started talking with his friend over WhatsApp, over social, Facebook, or maybe he started browsing some automobile company's website, right? But as a automobile company, I'm not aware about what my customer is doing. I'm not aware about the interest of my customer. What is the phases of my customer, where he's going for, what is doing, what even he's, see, these are some confidential information. There is proper NDA when you collect the data. You cannot deal with entire information, but by collecting this information, at least a particular moment of my customer I can capture, right? Maybe he's having birthday, maybe he's having anniversary, maybe he started quickly, suddenly he started talking about some new cars, right? If he started talking about some new cars, maybe he's interested for new car. So if I got the information he is interested for new cars, so I'll start sending personal campaign, or maybe I'll send my salesman directly to that customer and I'll ask, and I'll send some offer or invitation or some kind of occasion so that I can call my customer and have a discussion and show my existing right? So what is the idea of customer 360-degree? So each and every, it's just I'm talking about automobiles, but this is going to true across all organization. So I have collected all information which is not only structured, which is even personal or social information of my customer. If I have collected any point of time and my data is updating and I know my customer, even my customer is traveling abroad, so I have some information, let's say WhatsApp message, I got WhatsApp message or maybe Facebook message. I know my customer is not in town, right? So if my customer is coming back, he's trying to, again, he started talking about new cars. So I can think about this is the right time to pitch my customer. Unnecessarily, I'm not annoying with the wrong campaign and wrong masses, right? So now, whenever I know my customer is behavior pattern by having complete information, because without having complete information, you cannot know about your customer. So so that is where we are trying to collect entire data and having single view of the customer. That is called customer 360-degree. It means complete information of my customer. By having complete information, I can I can convert, maybe not right now, over the period I can, when he's ready, really ready for the new cars, I can start promoting a special campaign, or I can sell direct sales contact, so that I can convert that customer into actual customer, right? That is one use case. Second use case, I have I have already sold my car, and he's getting this repaired or service every month or every uh, week in service center. So moment he's going with the service center, he's filling some feedback form, right? Whether he's satisfied with it. Because after selling, there is a huge opportunity to grow revenue by selling parts. And how parts can be sold? If your customer is satisfied, he's coming to your service center properly, right? So one time earning is by selling car, but the regular income, how it can come, how it can occur? By servicing the vehicle, right? So if you know your customer sentiments with your service, if we sometimes I had a bad experience with the service center, right? Or so if I have information of bad experience, then I can quickly rectify that bad experience, right? Quickly rectify. Maybe I can ask customer, call directly customer, I think you're, why you're not, what happened wrong with your service? Is there any problem? If something is not okay, just send again. I'm sending, serviceman to pick up your vehicle, and it will get reservice, and you don't have to pay. This kind of service you can improve. You can convert your negative sentiments into positive sentiments, so that you cannot lose your customer, right? So how come these kind of use cases is possible? Unless you don't have complete information of your customer, from buying vehicle to servicing vehicle to interaction over the social media to having a special moment of his life. Unless you don't have all complete information, you cannot make direct or personal connect with your customer. If you're not able to make it, so probably you're losing business. That is where there is so huge competition in even across all sector, but in automobiles there is huge competition as well. So now using the data science or data analytics or big data kind of platform, they're trying to beat the competition, right? So beating competition means trying to retain the customer and trying to bring new customer by having a special and customized marketing and promotion campaign. And these are the technology which is actually helping. So you can think about, how Hadoop kind of platform is actually helping. And without this kind of technology, it's not possible, right? It's not possible. Even, insurance sector, one of the very good use case in insurance sector. Now premium is going to be decided on real time basis. It can vary. It can vary from, maybe last time I have given premium of around 30,000 for my new car, right? So this time maybe it can vary from 500 rupees to 20,000. How it can vary 500 to 20,000 premium. So now automobiles company is trying to implant sensors and IoT devices in the car, right? On real time, they are monitoring your car. Even insurance sector, it's one premium, and the second loss insurance company is getting by fake claim. They're trying to reduce the fake claim. Why? How they are trying to reduce your fake claim? For example, you made some accident, right? You made some accident, and that accident was mistake. It's your mistake, but somehow you have converted into within the criteria of insurance company. So you have made some mistake. You have given some bribe to agent who have inspected your car, and then your insurance has been approved. Though this was not the mistake, this was not the criteria covered by insurance company. However, you have claimed it, right? So to reduce this, they are implanting all these IoT sensors and devices, and they are real time. They are having complete information of your car, what speed your car is running, where it was running, how much, what speed you have when you met with accident, what speed you were driving, right? And what was the driving pattern? If you're drunk, so probably your driving pattern may be zigzag, different, right? So by having this real time information, they're trying to relate. If you unfortunately if you met with accident, they can relate whether this particular criteria was within, because you're doing something wrong. You're drunk driving. Drunk driving is not covered at all, right? You're driving drunk driving, right? So we got to realize how you're drunk driving, because we have monitored the pattern of your cars, and probably even inside the car they are putting some sensor where they can smell your order, right? So they can realize which situation you are in, and based on that facts they can provide claim. So by using these kind of, how this is possible? This is possible by doing real time analytics, by collecting, since when sensor is applied they are generating huge amount of data. Once you don't have a real right platform, you cannot collect data. Even you have managed to collect, you cannot analyze in the right point of time, right? So for these kind of huge cases where they have a huge opportunity to save money, to apply to provide the right premium, how the right premium is getting now calculated. Because when you're driving, so what is the, how well you're driving, what is the pattern of driving, how much class you are using, brake you are using, what is the speed you're driving. So in that base they are deciding the depreciation of your car, wear and tear of your car. Based on wear and tear and depreciation, they are calculating the premium, and that premium is not going to be standard. That premium is going to fluctuate from 500 to 15,000. If I'm a good driver, I'm taking my car well care, so probably I'm supposed to pay only 500 or 1,000 or 2,000 premium, though the cover of amount being covered is complete as rest of the car. So you can think about, there is huge opportunity to use this platform to do this kind of analysis across any organization, right? So if you have insurance company, then Hadoop is going to perfectly fit for you, right? Even inside your infrastructure. So you have your insurance website over here, insurance website here, which is actually connected with RDMS data. IoT data is coming somewhere from here. Let's look at here, sensor, right? Sensor machine. IoT data is coming from here and it is collecting here, and then you're analyzing, and then you're sending that information to that RDMS, and that RDMS information is reflecting in my database, my application. So at real point of time, I know what is the situation of this particular customer's car, right? So I hope now you guys are convinced with this architecture, right?
Bhupender, I have a question
Yes.
here. So the use cases you talked about, like 360, a customer 360. So if I want to apply for that position, what will be the means name of that position? So it will be not like big data analyst or something.
No. So it can be definitely big data analytics, or big data engineer, or big data or a data scientist. So customer 360 degree, what does it mean? You have collected data and you are doing some analysis, right? Customer 360
So
degree is
these
kind
are
of an,
so customer 360 is a combination of big data plus data science using
absolutely.
other
See,
tools.
yeah. So, customer 360 degree, so there is two part. One is data collection, data management. Second is analysis. You have collected data, you have managed in a single place. That is the 360 degree view of the data. But to find the right information out of data, you you need some analysis. You have to do some analysis, right? You have to do some processing, right? So whatever I'm talking about, these are the typical big data analyst, big data analytics use case. It's not beyond that area, right? Only data collection does not make any sense to you. You have collected data, it's just waste. But if you're finding, extracting some information out of that data, then it makes sense to you. And how you can extract? By doing analysis. Correct?
I got it.
Okay. So this is again the previous architecture. Now, what time? How much time we are left? 30 minutes. Okay. Now, see, we have talked about so much. I mean, how the architecture-wise Hadoop is fitting into in your legacy system. But what was the motivation behind this Hadoop? Why Hadoop came? Even necessity is invention in mother of invention, right? So, what was the What was the requirement? Why they started thinking about this Hadoop?
For storage into distribution systems.
Exactly. That is one very
To
good point.
enable distributed processing and distributed storage.
Absolutely right. But for that we have distributed system as well, right? We can live. We even before coming into Hadoop, we have distributed system, right?
But variety of data has increased, like from social media or the IoT. These things were not there.
So absolutely right. You're trying to connect what we discussed so far, but let's think about little more perspective. What was the motivation behind Hadoop, right? So we know motivation for Hadoop. What were the limitation for earlier large scale computing? So even if you go with the we have even mainframe, right? We were doing all those mainframe, and even we uh, if we if you try to think long back, if we go long back 20-25 years before, there we have a small, there we used to have one small computer, right? From a small computer we were dealing with the small data sets, right? Over the period technology has been upgraded. My single machine has been capacity has been increased. My RAM has been increased, RAM capacity, my CPU processing capacity has been increased, but that was limited to single computer, right? So we started solving little extra amount of data, but the data size is growing, so we need more powerful system. So even we have grown with the powerful machine. Then we started connecting multiple computer and came up with the distributed architecture. Then we started connecting multiple computer. We came up with the distributed architecture. So distributed architecture. So by putting my data on a distributed system, we were able to manage that data, right? We were able to manage the data. Even we have the distributed system. So then what was the requirement for Hadoop? Right? So if you go with the Hadoop will look like Hadoop is again one distributed architecture, right? It's if you go definition of core component of Hadoop, which is called SDFS, Hadoop Distributed File System. That is distributed file system. That's all, right? So we grown up with the single computer to distributed computing. But by growing with the distributed computing, so we had issue with the synchronization of data exchange, managing the bandwidth within the distributed system, and controlling the computation. So as a programmer, if I have to manage my data in distributed system, or if I have to analyze my data in distributed system, I had to think about, I had to write my program in distributed architecture perspective. So I had to code extra line of codes to even control the distributed architecture perspective. What is architecture? I have to think about the synchronization properly happen. For that synchronization, I have to use synchronization programming concept in my program, right? I have to think about, I have a limited bandwidth within my distributed architecture. Limited bandwidth means network bandwidth. So I have to think about what kind of bandwidth should be assigned to this particular task so that it should not choke my network, right? So these are the things I have to programmatically I have to think, and I have to write in my codes. So ultimately I started with writing code to process my job, but rather than processing, I started thinking to even write code to manage my infrastructure as well, right? So over the period, we realized we have grown with the huge number of code, and my logic from analysis shifted to managing infrastructure. That was the real problem. Even a small amount of processing I was supposed to do, let's take an example, select count from blah, and my data is actually distributed. For doing only select command in distributed data, if I'm using my, if I'm writing programs, so I have to think about how it is managing. I have to think about synchronize. I have to think about aggregation. I have to think about. So though it's very small logic, but over the period we realize we have grown with the huge line of code, and my analysis shifted. So actually, rather than focusing on logic of analysis, my logic focused to code and managing infrastructure via code, right? So that was the problem, and that is not doable for each and every analytics, right? You should be very good in programming at least, otherwise you cannot do that, right? That was the problem with the distributed architecture, right? So one of the very good huge the article, Leslie Lamport, again one of the computer scientists from US, and he has written this very nice blog on fallacies of the distributed computing. If you go with the distributed computing, right, earlier everyone, I mean, if you are having distributed computing with a very fast network, very fast supercomputer applied, everything is there, and you're claiming it is going to help you to process your data without fail, but that is not true always, right? So he has written this line, he used to quote it, you have distributed system when the crash when the crash of a computer, where you never heard, stops you from getting any work done, right? So what it's trying to say, whenever you go with the distributed system, he is proposing distributed system, he's saying if you have applied this distributed system, it is not, your job is not going to fail at all. It will not stop you, your job will continue, but that is not true. So for distributed system, this is very nice blog, Fallacies of the Distributed Computer. I'll share with you guys to go with. So he has mentioned, what are the fallacies, what are the false promise they have made with the distributed system. Even if you go with the cloud is proposing, right? It's cloud infrastructure. Your system will be available any point of time without any downtime. That's not true. Don't believe in any kind of cloud. They are based on the distributed architecture, right? They are meant to fail. But how we can overcome from this, how we can counter this fail? We should have some system which can actually support even my distributed system is also fail. Even my distributed system is failing. So it does not stop me to do my job, right? So point is, even if you have cloud, even if you have very good network, very good infrastructure with the distributed computing, and you're saying, don't worry, your job will be executing, it will not fail at all. Don't trust at all. That was happening, right? Even everyone, saying, I mean, it's distributed architecture, it is not going to fail. You can load, you can scale, it will survive at any point of time. But it's built mean to fail. But what was the situation? How we can? What are these? Then how we can counter this kind of problem? Then how we can counter this kind of problem? We'll discuss it. So counter means, even I know my distributed cloud is there, everything is there, but I know it is fail. So what kind of activity we do to even overcome this problem, right? So if you go with the distributed system, so whenever we are having data is actually stored to different machine. But when you have to process, data is traveling from one machine to your processing logic. So if you think about, so in distributed in even legacy system, so we have the architecture, your data is distributed. So let's take an example. Even in current architecture, if you go with, you have a storage, right? Storage, you have one computer which is connected with a storage. Your data is actually stored some storage, NAS device, right? But your processing power is where? With your computer. But when you have to process your data is actually coming from storage, NAS storage, to your computer. So ultimately your data is traveling. So think about, you have some processing logic you have written, and that size is, maybe MBs, but it cannot be more than MBs of code, right? If you have written some processing logic, you have done some programming to process some data, the size of complete program would be maximum in MBs, right? But the data you want to process, it is in GBs or terabytes, but that data is actually stored in backend. So let me, for the new, so this is your computer, right? And this is your storage system, and this storage system is actually connected with network cable, right? If you go with the distributed architecture, so you have multiple computers, right? You have multiple computers, and their storage is nothing but centralized storage. Sorry. Your storage is nothing but centralized storage, and this is, you can call, this is storage. There are different storage vendor, they provide this storage. This is storage, means the hard disk, collection of hard disk, right? And this is your computer 1, computer 2, computer 3, right? So in this computer, what you're doing, you have here your actually CPU and RAM is actually specific to your computer, which is local to your computer. But your data is actually in the background. You have a huge set of data you have stored in some storage system, right? When you're doing analysis, you're logged in this computer. In any of this system, you logged in, and by logging into, you're executing your program. So by executing program, So your data, let's take an example. Here you have 100 GB of data, but here you have a 2 MB of program. Maybe here 10 MB of program, or maybe maximum if you have written very heavy program, it can go to 2 GB or 5 GB. You can think about size of your program is 5 GB, right? Right. So when you are executing your program, so on 100 GB of data, so your data is actually traveling from here to here, because your computation is processor bound, right? Since your processing power is available here, it is going to execute. So ultimately your data is traveling from here to here. So think about, if your data is traveling from here to here over the network, so think about the kind of performance issue you can arrive, because this network is having it's having limited bandwidth. It's not having its maximum. You can go with the 10 gig of bandwidth, right? So at a time, if you're utilizing 10 gig of data, you can transfer in this bandwidth, right? So in distributed architecture, what is happening, your data is traveling to your computer, because your computation is processor bound and your processor belongs to this computer, right? So since your huge set of data is traveling to this computer, it is actually encounter performance issues, and this has been, and we'll see how it is going to be fixed by Hadoop architecture. These are the very interesting things. Interesting things means how the entire evolution happened. What are the, so it will help you to actually understand, to clear with your architecture concept, right? So now we are talking about, we have the data actually distributed system, and it's coming to over the computer, over the network. But over the period, if data size is growing, what amount of data we are expecting? We're expecting, this is some stats we have, right? Facebook into 2016 is used to generate at 500 terabyte per day data, right? Can you think about 500 terabyte of data they can transfer over the network to do analysis? But they are doing analysis. This time they are doing analysis. Why they are using? They are using Hadoop kind of technology, right? So this is the problem. If this kind of size of data we have, can distributed computing solve this problem? So this is some for your information. If we are going with the size of data, how the data size is actually increasing. We started with bytes, kilobytes, megabytes, gigabytes, petabytes, gigabyte, terabytes, petabytes, and exabyte. Now gigabytes data is also there in the market, right? So just for your information, this, I have shared this data size detail. So now we have seen, so far we had discussed the distributed computing problem. We started with a small computer, we grown with the powerful computer, and we grown with the distributed computing. So by the growing the size of data, we grown with the concept of the distributed computing. But even distributed computing is not solving all my problem, right? So because if one node is failing, my entire job was failing in distributed computing. So we should have some system in place which can actually fix this problem. So there, the requirement of Hadoop actually started coming into picture. So they started thinking about, we should have some system in place which is actually can deal with the partial failure. Maybe my distributed architecture, one node fail, does not matter, even though my job should run, right? Let's take an example. We have 100 terabyte of data processing, right? And one node process 1 terabyte. In distributed computing, if one node has been down, it means your one node is processing maybe 10 terabyte out of 100 nodes, right? 100 terabytes. So if one node failed, it means your 900 terabyte of data. So entire processing is actually lost. So we should have some system in place which is, even one node or two node is failing, even though I'm able to sustain to get the result out. Because in big data scenario, you're processing huge amount of data. So if something is in distributed architecture, something is failing, you should be able to sustain it. Otherwise, you have to again start from the scratch, right? And it should be it must be scalable. And at any point of time, you can scale without bringing system down, without impacting your job. If job is running without impacting your job, you can scale your compute, right? So partial failure, what they is what partial failure is talking about. Even if one component, one node is failing, even though we should be able to sustain, right? So scalability. Now for these problems, these are the basic requirement we started with. I mean, community started with thinking about designing a Hadoop. We should have some system which can actually looks like distributed system, but it should be able to deal with the partial failure. It should be able to deal with the scalability, right? So then they started thinking about, and they came up with this new technology, which is Hadoop, right? Hadoop is again open source technology, but how they are fixing that problem in Hadoop, I'm going to discuss. What is partial failure? What is the data traveling, right? Data is traveling from storage to computation. So there we have the Hadoop in different logic. They have done reverse engineering. So this is actually open source free software, and it's crafted by Doug Cutting, Mike Kerfella. Doug Cutting is founder of Cloudera, right? So he has adopted this logo because his kids was actually playing with the stuffed toy. So yeah, elephant type of stuffed toy, and yes, he used to call Hadoop.
Bhupendra, I think it was not his son; it was her daughter. His daughter.
Sorry.
His son was not playing with the toy. His daughter was playing with the toy.
Okay, maybe. Anyway, maybe you try to it was its son, right? Try to clarify, but I'm pretty sure it was his son actually. So anyway, ultimately, so Doug Cutting has kids. He used to play with stuffed toy, which name is elephant, and that has been actually, so from that he adopted this name Hadoop, whatever he designed, architected with this kind of architecture. So that was the name, I mean, convention, how it is picked up. This is just interesting story. Other than that, nothing is there. Then based on the, and how Doug Cutting before Doug Cutting joined Cloudera, he was part of the Google, right? So even in Google, when they started about Google published this white paper, which is called Google file system, right? So it was written around the Google file system. Later on, that Google file system has been converted as Hadoop file system, HDFS. So based on white papers, right, they started working on this, and they came up with this new open source freeware technology. And the core idea of the distributed computing was that rather than traveling data to program, if you go back, so core idea, rather than traveling data to computation, they converted computation, your program traveled to data rather than, because data size in any case it is going to be huge. So rather than making your data to travel your computation where your program is residing, your program is traveling to data. So that's called data locality concept. That's called Hadoop's data locality concept. So if your program size maximum going to be MBs, so it can quickly travel, and in a very fast manner it can travel to your data. And once it's traveled to data, it is going to sit with your data, and then that's called data locality concept, right? Your data and program is sitting together. So here in this architecture, your program is actually traveling to data. So that is what they have changed in their design process, right? So that actually help them lots to fix the problem of distributed computing. Also, they managed to fix the partial failure. Even out of this distributed computing, if one machine is failing, their job is not getting impacted. Now Hadoop is giving guarantee you. This is one value proposition of the Hadoop. When you propose within your organization, Hadoop is giving guarantee. If you don't have bug in your code, if there is no problem with your code, your data is okay, you have tested well, so you just port your data and port your program inside the Hadoop cluster, irrespective of the size of data, irrespective of the program. It is giving you guarantee to process it. It will come back with the result, not like the legacy system. In legacy system, if you go with, we have been victim of those problems. Our job is running over the weekend, and our same job is running weekend without any issue, but one weekend, the next weekend we found it failed because of some processing capacity, because of some network latency, because of some timeout operation, multiple reasons it failed, right? So in any point of time, even if you're very sure, but you cannot give guarantee, it is going to process your legacy system. And here in Hadoop, if there is no issue with your program, it's not buggy program, it's your data is okay, then it is giving you guarantee to process it, irrespective of when machine is failing. Out of cluster, if one or two machine is failing, it is giving you guarantee to process it. How it is giving guarantee, what are the intricacies, what are the design logics we have, we'll discuss in detail in architecture, right? So that is the idea behind this invention of the Hadoop, and over the period has become more powerful. Lots of changes has been happened, lots of new technology, ecosystem components is around there, we discussed in last class as well. But the core concept they have, the core Hadoop concept, it's actually written in a, right? So one thing, if you remember, we were talking about in distributed system, we even to manage my data, I have to write program to manage distributed architecture as well. So over the period, my program was increasing, not because of processing logic, because of managing infrastructure. But here, you really don't have to write any distributed programming logic. In Hadoop, you just write with your processing logic, analytics logic. And the distributed architecture, it is Hadoop who is going to take care, right? So it makes life very easy. Otherwise, you have to be very good programmer to even deal with the distributed computing as well, right? So now people started focusing on analysis rather than programming. Also, apart from the data locality, traveling data rather than data, they started traveling program to data, right? So they have also came up with the concept of shared nothing architecture, right? So each and every node, they are not sharing any information to each other. Inside the cluster, their nodes are not sharing information to each other. So if they are not sharing information, it means if they are failing, so it does not giving any impact to other nodes because they are not sharing the information. So perform computation where data is already stored rather than moving data to program. Now, this is the high level core concept and architecture where they started thinking and came up with this architecture, Hadoop kind of technology. But behind this, what is the core concept they have? What is the core component you have? We can quickly discuss. The core component they have SDFS and MapReduce, right? SDFS means for storage, right? How you can manage your storage in distributed architecture. Earlier we used to have a distributed architecture, we have lots of problems that has been fixed by SDFS. Now MapReduce is nothing but your processing. It is called MPP, massive parallel processing. It is actually helping you to process your job in parallel, right? So whenever this is the two core component of Hadoop, right? So one is SDFS. Your entire Hadoop architecture is actually roaming around this two core component, SDFS and MapReduce. So SDFS is nothing but storage. So they started thinking about storing data. The storage unit in SDFS, they have treated as a block as a storage unit. So they came up with the concept of blocks as a storage unit. Even in disk, your data is actually being stored inside the block. Ultimately, your data is stored inside the block, right? So, but in Hadoop, they have adopted the size of block is actually, so whenever you go with your system, so you can find your block sizes, your hard disk block sizes 8 KB, probably 4 KB, 8 KB kind of block files you'll find your hard disk where data is actually getting stored, right? In Hadoop, the block size they have increased 4 KB to 64 MB. This is the minimum block size. Earlier, it used to have a 28 MB, the minimum block size. But now the default block size is, which is coming with the all cluster, is 64 MB, right? 64 MB, and you are pretty much free to increase the block size. You can increase with the 128 MB. You can even increase with the block size of 256 MB. You can increase with the 512 MB block size. So look at here. What is the difference? My normal file system, when I'm storing my data, file system, this is the window machine I have. So window file system, my data is getting stored with the help of window file system, NTFS or FAT file system. If you look at, there's the file system, right? If you go with the Linux, there is a file system XFS or ext4. These are the file system we have in Linux. But the size of block they are using to store data in the unit of 4 KB or maximum 8 KB, right? But here they have increased the size of block. This is Hadoop distributed file system. They have increased the size of block to minimum 64 MB. To minimum 64 MB. It used to be earlier 28 MB, but now by default it's coming with the 64 MB. But on top of that, you are free to increase. Just by changing small parameter, you can increase the block size. But what is the advantage of block size? What is the advantage of block size having this bigger block size? So advantage of the block size, since now we are talking about the big data, right? So let's take an example. This is just hypothetically, this is one disk you have. Hypothesis, I mean, just we are assuming this is one disk, and one disk is having, these are the blocks you have. These are the blocks where your data is getting stored, correct? Let's take an example of, in window, this is 4 KB of blocks. Or a Linux, this is 4 KB of block. Let's take an example. If you have let's take an 100 MB of data you have to store. So how many blocks you're going to occupy in the disk in Windows or Linux file system? Divide 100 into 1024, then it will be converted as a KB, and divide this with the 4. How many blocks it is using? So if you have 100 MB file, I'm talking about very small file size. If you are storing on Windows, so or Linux, it is going to occupy it internally on a disk. Ultimately, data is getting stored on disk, and disk is storing data in the blocks, right? Disk has a block and sectors, right? Inside that blocks storing data. So your data is this 100 MB's data is going to be stored in 25,600 blocks. So like you have those many blocks there, it is going to occupy. Let's just think about this is 25,600 blocks, right? Whenever you are trying to access data, what it will do internally, what is happening?
Each block has
It is your cursor is going, your internal disk cursor is going to each and every block, collecting data, then coming back with the complete information. If you remember long back, I mean not long back, if you go with the low performance computer, if you have heavy file Word or Excel, if you click it, it is taking time to open it, right? Because it is actually traveling to entire blocks, and by traveling to entire blocks, then it is coming up with the complete information. So ultimately it has to travel these many blocks to give you this 100 MB file information. But if you go with the SDFS, this is the design advantage. If you go with the SDFS, we know block sizes, default block size 64 MB, right? So on top of this block, this normal disk, I have configured my block size. I have configured my block size to 64 MB. One block size I have configured to 64 MB size, right? So now think about, I have to store 100 MB. How many blocks SDFS block it is going to occupy? It's just two. So traveling 25,600 block, then traveling to two blocks, which is faster? Of course, two, right? So that is one good design they have think about by having this block size, bigger block size, right? So that they manage to deal with. I mean, it's not easy to deal with the big data, right? So there are lots of intricacies. There are lots of minor things they have think and they have fixed to come up with this kind of technology. So that is the SDFS perspective. Now the unit of SDFS block is minimum is 64 MB, but you can reduce to 28 MB. You can go with the 512 or 128, or it's up to you. It's pretty much configurable. Just have to change one single parameter. I'll tell you where you have to change and why it is giving advantage having smaller block or bigger block. What is the advantage? And what is the ideal block you should go with your cluster? That is also very important thing, because that is actually depend on your complete processing and complete assignment of the job. We'll discuss in detail. So, but this is perspective with the SDFS perspective. Now, second core component they came up with the MapReduce, right? So MapReduce, what they did, they have suggested you don't have to write distributed programming logic. Here, you don't have really right to distributed programming logic in your processing. What do you have to do? You have to just follow the convention to write your MapReduce, to write your program so that MapReduce can process it. So what convention you have to follow? You have to write your program in MapReduce way. What is MapReduce way? You have to write program in mapper. You have to write program in reducer. Right? You just have to write your program in two convention, that is mapper, and second two convention, that is map and reduce. You just have to follow this convention. That's all. And forget about your distributed programming logic. You just focus your processing logic, but just try to write your program in map and reduce way. What is map and reduce way? We'll discuss in map and reduce way. How when we'll discuss about map reduce programming, we'll have a complete detail about how to write my program or processing logic in map and reduce way. This is just two philosophy. This is just two, very important core component. They have captured entire problem with the distributed system, and they managed to deal with the big data with 100% guarantee. Your data is not going to, it is not going to loss, and it will come back with the proper processing result, right? And it is also having fault tolerant and failover. All these concepts will discuss architecture. What are the other features we have there? What is fault tolerance, failover, automatic failover, how it is managing resiliency itself, right? Clear?
So one question, if you have the 8 GB data, then can we give the size of one block is 8 GB?
No, no. It's not. Earlier it used to be, it was supporting minimum 28 MB. Minimum 28 MB. That was default. Now default has been changed to 64 MB.
What is the maximum?
Maximum you can go with the, so far I have tried 512 MB. But beyond that I have not tried, and I'm not sure where with the maximum number, seriously. So but we can figure it out.
Even higher block size, it means wastage of storage, you don't have that kind of data.
That is the good question, right? But Hadoop is also, so that actually reminds me to go back this particular block what we are actually talking about, right? So in normal window file system, this is your window file system, right? So let's take an example. For example perspective, I have 10 KB of file. I have 10 KB of file. So 10 KB of file in window is going to occupy almost 3. Almost 3. But third block, it's not completely occupying. It is occupying half block. But the half block size is wastage in window or Linux file system. But in SDFS, it is not waste. It is going to be used by, so your this 64 MB, let's take an example. We were talking about here 100 MB files, right? So now 100 MB files is going to occupy almost 2 block. Almost 2 block. But it's not completely 2 block. It's almost half of the block it will occupy. Rest of the half block is free. But it is going to be used, reused. It is not going to free. In SDFS, that is where we have value proposition. You can save your wastage of disk as well. Right? And I'll discuss in detail how it is being managed when we'll discuss in architecture. Right? Clear? So for the sake of time, we are almost already 15 minutes old. Okay, let me quickly go through if how many. Okay. I think I should stop now, right now. It's already 15 minutes over. We have almost 5-7 more slides to be discussed. So we'll resume tomorrow.
Right. Share this document to LMS?
You'll be, it is going to be uploaded, yeah. On LMS, you'll have a link there. You can click and you'll find these documents. By default, this video is getting uploaded automatically, but the material, what I'm sharing you, I'll upload there and you'll find there. Right? So it's already 15 minutes over. So I'll stop my further discussion because it's already over, right? I hope now it's moving on top of head, right? But these are the very interesting things, right? So over the period, you realize what is the advantage we have to understand these things, right? So, but we have a few more slides. We'll resume tomorrow. Before leaving for the day, any questions, guys? Online and offline, any questions you have? Yes?
How do you see the state of Hadoop after 12 years of journey?
Wow, that's a good question. If you try to relate the last discussion we have, see how Hadoop started. Hadoop is actually based on the distributed architecture, right?
Bhupen,
And they have
Bhupen,
fixed.
can you repeat the question?
So his question is, his question is how, what is the you can say scope of the Hadoop down the line. I mean, maybe let's say after 10 years or 12 years, right? So maybe so we are around here. So maybe after 10 or 12 years, you'll remember me. Why we are? I'm focusing on this architecture, right? Whatever new technology is coming into, but the logic, but the internal architecture, it is going to be almost same. It is not going to be changed drastically, though there would be new technology in the market, definitely, for sure, even 1 or 2 years after you realize it, right? And even though we were talking about Flink and Storm, all those technology is actually already came into market, right? But the processing logic, but the architecture, but the context, but the internal architecture, it is going to be almost same. So try to understand, we started with the distributed computing, right? Even Hadoop is based on the distributed computing, but it fixed some problem. So Hadoop is based on the distributed computing. Whatever the new technology is coming into, it is going to be around that concept. There would be small changes, plus or minus, otherwise it will remain same. So don't think on technology perspective. Think on business perspective. That I always used to tell my students, right? So don't learn technology, learn business. Technology is enabler. Over the period, it is actually enabling you, right? So here we are going to learn business as well as technology, right? But the architecture, it is going to remain same. Whatever the architecture, it is going to remain same. I mean, last 6 7 years, I realized, I started from where, and I'm even roaming around that, just fixing some my concept here and there. Otherwise, I'm roaming with the same concept. So get it properly. Thank you very much for the day. Let's connect tomorrow.